terms of a linear model. Okay. And the transfer function is defined using Laplace transform. Okay, I believe you already learned about Laplace transformation in in ODE. Okay, so basically for a transfer function, we use Laplace transformation method with considering the initial condition, right? Initial condition equal to 0, and then we solve the equation, we get the solution, meaning you're going to solve all the parameters there using partial fraction method. Okay, first step, of course, Laplace transform. You convert your final transfer function into Laplace form. Okay, and then you solve for the parameters using partial fraction method, and then you will inverse back the Laplace transform into the ODE again. So the final equation in ODE form is actually the time response and also the transfer function for the system. All right, so okay, so we use the transfer function to describe the dynamic behavior. Okay, meaning we want to see how the output will behave when we apply the input. So we can see the dynamic behavior, how it change. Okay, so normally it is in time. Okay, the changes is in time. So we can see first we go up, then we go down, go up, go down. So that is what we call as dynamic behavior, that the behavior is changing. All right. We also use a transfer function to describe the relationship between the system input and output. Okay. Right. First, we describe the dynamic behavior, and then we use that to discuss the relationship between the input and output. Okay. So we can see how the system change when we apply the input, and then we will be able to see the behavior in terms of output. All right, but the transfer function, by using transfer function method, we do not have information about, okay, does not provide, okay, does not provide information about internal structure and internal behavior of the system. Okay, because we just consider the input and output. But in the transfer function, actually there are many other elements, but we just combine it together. So if you only have the transfer function without knowing other element, so you cannot determine what are other elements in there. So because the transfer function cannot provide the information about the internal structure of the system and also the internal behavior of each of elements in the system. Okay, so we can just see the behavior of the system based on the input and output. Okay, but in the system, the internally, we cannot do the analysis on that. Okay, the information about internal structure, internal behavior can be get if you're using a block diagram system. Okay, meaning we draw the block diagram, so we can get we can know the flow, we can know the internal behavior, meaning for the spring, how it will behave, for the damper, or how it will behave, for the mass, how it will behave. We will be able to see that. Okay. All right. All right. So let's consider a transfer function that represent by the following differential equation. Okay. So this is the transfer function. Here, x is the output. Okay, FA is the input. Okay, so we apply FA to the system, and then it will the displacement x will change. Okay, where based on the input given, whether the input is pulse wave, step input, sinusoidal input, so that the output will behave depend on the type of the input. Okay, so so if we write the normally we're going to write the transfer function is the ratio of the output over input. Okay, this is transfer function. Ratio of output, X is our output, to the input, which is FA. Okay, so therefore the equation will be like this. So first we need to separate X from there. So we have MD squared X, okay, plus CDX plus KX equal to FA. Okay, notice FA is in time because X also in time. Okay, but because there is d over dt, so we just write X there. All right, so we're going to separate this. So we have MD2 square, MD2 square plus CD plus K multiply with X is equal to FA. Okay, so if in terms of transfer function, it will become X over FA is equal to 1 over MD square plus CD plus K. Okay, so this is the transfer function. Right, so 1 over MD square plus CD plus K is the transfer function, where we know M is the mass, C is the damping coefficient, K is the spring stiffness coefficient. So we will have the value there, right? So it will depend on the system itself, how much weight of the mass, how much damping in the system, and how stiff is the spring in the system. So different design of the system will provide you different output. Okay, so this is the example of transfer function. So now the objective of our part here is to determine the final transfer function here, which is 1 over MD square plus CD plus K. Okay, or 1 over JD square plus BD plus K. Okay, or kalau liquid level 1 over liquid level ada apa tadi? CD, okay, CD capacitance, CD and 1 over R. Okay, so all the constant that will be in the transfer function. Right, so now we're going to get the final transfer function here based on the block diagram that we have drawn. Okay, so okay, for example, this block diagram. Okay, as I explained before, this block diagram, okay, we're going to get the final transfer function. So the transfer function maybe become like this: R1 over C1D C1D plus C2D plus R2. I don't know. Okay, this is just an example. Okay, so we want to get this final transfer function, but we're going to use the block diagram simplification method. All right, meaning here, block diagram simplification method is we will need to simplify this block diagram. Okay, so there are actually basic 5 basic rules. Okay, we can use Okay, maybe we need to move this block pick off point. Okay, maybe to here or to here. Okay, we need to move this maybe to somewhere else, maybe to here. Okay, we can solve the feedback loops. Okay, so we will do that step and eventually we will get the final transfer function. Okay. All right. So this is the basic rules, the concept in block diagram manipulation methods. Okay. All right. So the first one here is to explain about summation point. Okay. Here you can see that whether this diagram, this one is similar to this one. Okay. Or this diagram, it is actually the same. Okay, the output is the same. A minus B plus C, A minus B plus C, and A minus B plus C. The output is the same. Okay, so meaning whether you draw like this, okay, this is normally you draw like this, like, okay, you said there are three variables, A, B, and C. So therefore you will draw three arrows into the summation point, right? But other than that, you can also draw like this. Okay, so meaning A minus B plus C. So let's consider here is A minus B and this one is plus C. Okay, so therefore we're going to solve for A minus B. So two variables, two arrows, A, B. Okay, it is the same, right? And the parameter is also, meaning you can put B first, A minus C first, A plus C, then only minus B, as in this diagram. Okay, so here A minus B plus C. Okay, three variables, but we want to draw only two arrows. Okay, only two arrows. So we said A plus C for this one, and here is minus B. Okay, so now we solve for A plus C, two arrows, A plus C. Okay, so this three diagram is the same. Okay, it will provide the same output. All right, that is the concept in block diagram there. Okay, so when you draw a block diagram, it not necessarily to draw just this one, three variables T arrow. You can separate to multiple summation point. Okay. Okay. For the concept of block diagram simplification method, okay, meaning if you see there are two summation point side by side. Okay, like this one here. Two summation point side by side. Then you can just combine it together, become one, like this. Okay, can become like this. Okay, or you see it is one summation point, but you want to separate it into two summation point. You can also do that. Okay. All right. All right. Okay. I said just now we have 5 basics rule. Okay. The first one here is not considered because this is just a concept. Okay. Okay. The first rule that I means is okay. Here we have a series block. Okay. So for a series block, you can in terms of positioning, it doesn't matter G1, G2 first or G2, G1 first. It will be the same, right? So for a series block, this is the simplification. After simplification, it will become one block only where you will need to multiply both block together. So for series block diagram, we're going to multiply it. Okay, so therefore we have G1, G2 or G2, G1. It is the same. All right, so that is the first rule. All right. First one is series block. Okay, the second one sorry, saya kejap. All right, sorry for that. Okay. Okay, first rules is series block. Okay, series block, you're going to multiply it. Second rules is summation point. Okay, summation point. Here, sometimes the summation point will, due to the summation point, we will not able to solve a series block or a parallel block. Okay, later I will show you the parallel block. Okay, so due to the summation point and peak of point, we cannot solve that. Okay, for example, if there is summation point here, okay, so we cannot multiply it. Okay, we will need to move it first. All right, so the choice is either you move the summation point toward the output, okay, because we consider this side is output, or you move toward the input. Okay, after you move it, then only you can multiply G1 and G2. You can combine it together. Okay, but if there is a summation point or peak of point between the block, then you cannot combine it. We will need to move it first. Okay, so for a summation point and peak of point, we can move summation point either toward the output or toward the input. Okay, it will be different. The transfer function will be different if we move toward the output, and then if we move toward the input, it will also be different. All right. So, all right, first is summation point here. So for this, rules here, this is when you move the summation point toward the output. Okay, so here you can see you move toward the output. So now the summation point is after the G block. Okay, because you move over G toward the output. Okay, so after you move toward the output over G, therefore you need to multiply with G. Okay, meaning there will be additional block there. Okay, before this, there is nothing here, for example, like this. So when you move it toward the output, now there is a new G will be multiplied, B here will be multiplied with G. Okay. This block here is due to the moving step, because you move the summation point, therefore you need to multiply with G, right? So that is when you move the summation point toward the output. Right? For this one here, right? This is when you move the summation point toward the input. Okay, this is when you move the summation point toward the input. So here you can see the new transfer function. And the new, meaning you need to multiply with 1 over G. Okay, 1 over G. Alright. Okay. For these two here, this is pick off point. Okay. So you just tap and fit into somewhere. Right. So here for pick off point, this one here is when you move toward the input. Okay. Therefore, you're going to multiply it with G. Okay. And this one here, you move toward the output. Right? So you're going to multiply with 1 over G. Okay? So that is for rules number 2 and 3. First one is series. Number 2 is moving a summation point, but there will be 2 there, toward the input and toward the output. And the third one is moving a pick off point. Okay, there will be also 2 toward the input and toward the output. Okay. All right. So to simplify that, we just remember 1 because it just vice versa. Okay. So you just remember that a summation point toward the output, okay, then it will multiply with G. Okay. Because if you move toward the input, it will become over G. Multiply with 1 over G. Okay. As the pick off point toward the output, it will be vice versa from this one here. So it is 1 over G. Right? And last one, pick off point toward the input. Okay. Vice versa with this one. So it is G. Okay. So therefore, just remember 1, summation point toward the output is G. Okay. From there, you will be able to determine for the other movement. Okay. Any question so far? Okay, we have three rules so far. Series block diagram, you're going to multiply it. Okay. Moving a summation point, you will have 2 toward the output and toward the input, whether you multiply with G or 1 over G, right? And then for the pick off point, it's the same. Moving toward the output, toward the input, you will also 1 over G and G. Okay. Any question on that? Am I too fast?
Doktor, boleh terangkan balik tak untuk summation point yang input?
Toward the input.
Ya.
This one. Okay. So when you move a summation point toward the input, okay, toward the input, all right. So you will need to multiply it with G, 1 over G. Okay, here you can see the arrow, the input arrow for the summation point is B. Okay, but after you have moved toward the input, B will need to multiply with 1 over G, meaning you need to add a block here. This block is 1 over G. After you move, before you move, there is no block, but after you have moved there, then you need to multiply with 1 over G. Okay. Basically, yes, if you just look on the rules here, you cannot imagine. Okay, later on the example, you will see how it happened. Right? Additionally, before that, okay. Mana saya dah tulis ya? Okay. Additionally, summation point and pick off point, okay, these two can only be moved over a block. Okay. So for example, Okay, for example, if we have a block, then we have a summation point. We have a block. Let's say this one is G1, this is G2, right? Then we have a peak off point here. Okay, right? So we said that now we're going to combine G1 and G2. Okay, however, due to the summation point here, and also peak off point here, we cannot combine G1 and G2. Okay, therefore we will need to move the peak off point and the summation point first. Okay, so when I said that a summation point and a peak off point can only be moved over a block, meaning here, right? Okay, so let's consider this summation point here. Okay, this summation point here, I said we can move toward the output and toward the input. But for this case here, the summation point can only move toward the input. Okay, it cannot be moved toward the output because there is a peak off point there. Okay, so you cannot move over a peak off point because we only can move over a block. Okay, similarly for the peak off point here, okay, the peak off point can only be moved toward the output. Okay, but it cannot be moved toward the input due to the summation point here. Okay, because there is summation point there in between the block, so the peak off point cannot be moved toward the input. Okay, so therefore in this case we only have one choice. As for the peak off point, we can only move it toward the output. Okay, peak off point toward the output. And as for the summation point, we can only move it toward the input. Okay, so that is meant by summation point and peak off point can only be moved over a block. Okay, all right. Okay, so that is rules number 1, 2, and 3. Okay, let's go to rules number 4 and 5. Tak naklah nangis. Macam mana? Adik. Okay, all right, let's continue with rules number 4 and 5. Right. So rules number 5 here, we have what we call as parallel block. Okay, but this one here is a forward parallel block. Okay, this one here is also parallel block, but this one is feedback. Okay, you can see there is 2 block that is in parallel, but this one here is forward. Okay, toward the output is forward. All right. As for this one, this is also parallel, but here we have a feedback. Okay, we feed to the back, so it feedback, right? So here, for parallel block, okay, For parallel block, we're going to add it together. G1 plus G2. Okay, so it become, you need to sum G1 plus G2. Okay, because it is a forward parallel block. Okay, so this is G1, this is G2. So in order to combine these two parallel block, okay, we need to add it together. So it becomes G1 plus G2. Right. As for the feedback, okay, in order to combine a feedback parallel block, so the equation will be G over 1 minus or plus GH. Okay, minus or plus that will depend on the sign on the summation point here. Okay, if the sign here is plus, okay, if the sign at the summation point is plus, and then in the equation, it will become minus. Okay, if the sign at the summation point is minus, so in the equation, it will become plus. Okay, so that's why it write minus or plus, because it depends on the sign at the summation point. Okay, so this is G over 1 minus GH. Okay, okay, so normally for forward block, we call it as G. This is forward block G. If it is a feedback, normally we represent it by H. It is just notation in control, but actually you can use any sign. Okay, so there is for two parallel block, we have forward parallel block. Okay, if you combine it together, that will become G1 plus G2. Okay, for a feedback parallel block, okay, we need to have to use the equation there. So the equation is G over 1 plus or minus GH. All right. Okay, one more concept that you need to understand is, for example here, if right. Okay, you can see here the feedback is only line without any block. Okay, so for a line, okay, we will consider the gain. Normally in the block we call it as a gain. So the gain here is equal to 1. Okay, so meaning there is no transfer function there, so we consider the gain is 1. Okay, as for here, as for feedback, it doesn't matter because G will multiply with H there, so it become G only. But for the for parallel forward parallel block, okay, so okay. All right. So if you are going to combine this forward block, okay, if you're going to combine this forward block, but here you can see that there is no G2. This is G2 actually. Okay, G1 plus G2. Okay, there is no G2, but we do know that for a line it is 1. Okay, so therefore the combination will become G1 plus 1. Okay, because G2 is equal to 1. Right? So for a line, okay, for any line, okay, the transfer function or the gain for the line is equal to 1. Right. All right, so that is the five rules. Okay, series block, you're going to multiply it. Moving a summation point, moving a pick off point, parallel forward block, you're going to add it together, and then parallel feedback block, you're going to use equation G over 1 plus or minus GH. Right? So you need to remember this step, these rules. So we're going to use that when we're going to simplify any block diagram. Right? Right. So let's do this example here. Right? So in this example, it will show you how to use the equation for feedback loop. Okay, because this is feedback, and this one also feedback. Okay, so both of these is a feedback loop. Right. So so first, normally we're going to determine what is the type of block in there, whether it's series, forward, or feedback. Okay, so in here we know that it is a feedback loop. Okay, second, after you determine its feedback loop, then you need to check, is there any summation point or pick off point that is that will meaning the summation point that we can, due to the summation point, we cannot move, we cannot simplify the feedback block. Okay, for example, maybe there are one summation point here. Okay, so if that the case, you cannot simplify using feedback blocks. Okay, we will need to move the summation point first. All right, and then all right, so since in this example there is no other obstacle, no summation point, no pick off point that we need to block, we need to move, therefore we can just use the rules number 5, which is feedback parallel equation there. Okay, so we know that the equation is G over 1 plus GH. Okay, plus because the sign here is minus. Okay, so we're going to do one by one. We're going to do one by one. First, let us solve for the first 2 parallel block. Okay, that will become one block. Then we're going to combine it with the last block there for the K. Right? Ya Allahu Akbar. Okay, so the first parallel block. Sorry for the disturbance here. All right. All right, so for we're going to solve for the first two parallel blocks. So we use G over 1 plus G. So this will become G, this one will become H. Okay, so therefore we're going to put into the equation 1 over MD square divided by 1 plus 1 over MD square multiply with CD. Multiply with CD. All right, so we're going to multiply it here, so we can cancel the two term here. So therefore, the equation will become 1 over MD square, because we already multiplied there, plus CD. Okay. Right. So the block will become, after you combine the first parallel block, it will become 1 over MD square plus CD. Okay, and then there is still a feedback loop for the K there. All right, jatuh anak. Okay, then you will do the same step for the for this feedback block. Okay, so again we're going to use the same equation, G over 1 plus GH, right? And now this one is G and this one is H. Okay, so similarly, so we have 1 over M ya Allahu Akbar, mana budak-budak ni? Sorry. Kena hantar anak ni kejap. Alright, sorry. Alright, so okay, we consider G is 1 over MD square plus CD. So there is G 1 over MD square plus CD. The denominator will become 1 plus 1 over MD square plus CD multiply with K. Okay, so similarly, we're going to multiply it here. Therefore, we can cancel that term. So the final will become 1 over MD2 plus CD plus K. Okay, so after we simplify, it will become only one block, because we already combine the summation point and the two feedback block. So you just relate between FA and X, which is in here is 1 over MD square plus CD plus K. Okay. All right. So that is the final transfer function based on the step of block diagram manipulation method. Okay, we do step by step. Okay. in order to get the final transfer function. Okay, so if you see this system here, okay, the system here, mass, spring and damper pulled by force here. So it is actually the same equation for this system. Okay, 1 over md2 square. Right, so either based on block diagram, okay, because before this you already draw a block diagram for the same system. Okay, you already draw a block diagram for this system here. All right, and then based on the diagram that you draw, we simplify it so that we get the final transfer function. That later on we're going to use that in order to know the dynamic behavior of the system. Okay, meaning to get the time response system, time response equation for the system. Right? Any question on that? Okay, so the example number 2 just now is just to show you on how to use equation of feedback feedback parallel block. Okay, because later on you will see you're going to use that equation in most of the meaning semua akan ada most of the step in the when you manipulate the simplify the block diagram, because eventually it will become to a feedback loop. All right. Okay, let's do example 3 here. Okay, example 3. Right, so we're going to produce the system transfer function, okay, which is the ratio of input and output, C over R. Okay, C is the output, R is the input, using a block diagram simplification method. All right. Okay, let's determine what kind of parallel block that we have here. Okay, if you can see, this is all feedbacks. Okay, because this one here is toward the feedback, toward the input, to the back. Okay, this one also is feedback. Okay, so meaning we're going to use to simplify the block using feedback rules. All right, so which one are we going to start first? The first loop or the second, the first feedback or the second feedback? Okay, let's consider this is first, this is second. Okay, you can start with any. You can start with second loop, you can start with first loop. Okay. All right, so we know it is a feedback loops. Okay, now let's determine whether there is summation point or peak off point that meaning that avoid us to solve the problem. Okay, let's consider for the first loop here. Okay, what is the element that disturb the shape of the feedback loops?
Summation.
Okay, yes, due to the summation point here, okay, we cannot combine that. Okay, if we consider the second loop here, okay, so for the second loop, it is due to the peak off point here. Okay, due to the peak off point between the summation point and G2 there, we cannot solve the feedback loops. Okay, so in order to do that, we have to move the either summation point or peak off point. Okay, so all right, so let's say that we're going to start with a second loop here. Okay, so if going to start with second loop, you will need to move the summation point toward the output. Okay, we can only move the peak off point toward the output because we cannot move toward the input because there is a summation point there. Okay, we cannot move over a summation point, then over a block. Okay, we can just only move over a block. So a block beside the pick off point is G2. So therefore, we're going to move toward the output, right? So if we move toward the output, the block diagram will become G2. And then here we have H2 R. Okay, but since we move the pick off point, therefore there will be additional block here. There is pick off point toward the output is 1 over G. Okay, right, and then this one here is still there, H1. All right, so now we can solve the first loop here. Okay, so try to use the equation, try to combine it. The sign is minus, this one is plus. Okay, try to combine it. Okay, so after you combine it, it will become okay. What will be the transfer function after you combine G2 and H1? Anyone? Ada yang dapat tak? So you will become G2 G. So okay, this is G, this is H. Right, so G2 over 1 plus G2 H1. Okay. And this one here is series. So we're going to multiply it. So it becomes H2 over G2. This is G2. Okay. So, all right. So this is a feedback. Okay. So we're going to combine this one here, series. Okay. And this one here is feedback. All right. So try to solve your feedback. You will get the final transfer function. Which is R and C. Right? So the input is R, the output is C. Right? So if you combine that, so G will become, G is equal to G1, G2 over 1 plus G2 H1, right? And H will equal to H2 over G2, right? So putting into our equation, which is G over 1 plus GH, okay, remember plus sign because the sign at the summation point is minus, okay? So our equation will become G1, G2 over 1 plus G2 H1 divided by 1 plus G1, G2, 1 plus G2 H1 multiply with H2 over G2. Okay, So, okay, so we can cancel this. Okay, because it's multiplied, so we can cancel that. Okay, after that, we're going to multiply it here. So therefore, the denominator will be the same. So we can cancel this with this one here. So it will left us with G1, G2 over, sana naik atas, 1 plus G2 H1 plus G1 H2. Okay. So that will be our final transfer function. G1, G2 over 1 plus G2 H1 plus G1 H2. Okay. So I hope you will be able to see the step in order to solve, in order to get the final transfer function using block diagram simplification method. Right? So just determine whether it's series, parallel forward or parallel feedback, and then check is there any summation point or pick off point that you need to move. Okay, so if there is summation point you need to move, move it first. Okay, then you can combine or simplify the part that you want to simplify. Okay, then check again. Repeat that process again and again until you get only one block that relates between the input to the output. Okay. All right. So I think I will stop here. I will share the exercise. Okay, in order for you to do the exercise so that you can check your understanding. You can check your steps there. Okay. Please do not ask for the solution because I don't have the solution, but you can try to solve it first and then show it to me, so I will be able to check it for you whether the step is right or not. All right. So with that, thank you. I'm going to see you next week because we don't have class on Thursday. All right. So our next class will be on next Tuesday. Right. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Doktor.
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 Thank you, Doktor.